Today I want to talk about the physical properties of planet Espa. Last video we tuned the orbit and its rotation, but that doesn't really tell us much about the planet itself yet. So let's get started on that. So what are Espa's physical properties? To start, Espa is more massive than the Earth, having 2.036 times its mass. Espa consequently is thus also larger than the Earth, 16,808 kilometers in diameter, making the planet about 132% larger than the Earth. From these values, we can derive the density and gravity. Espa has an average density of 4.8 grams per cubic centimeter, which is roughly 88% the density of the Earth. And while the density is lower, the gravity is stronger. Espa is experiencing 1.17 Gs, or an acceleration of 11.5 meters per second at sea level. I realize a lot of world builders go for a low gravity world, because it would allow things to get larger than they are on Earth. However, that's not what I'm aiming for. Evolution will adapt to the environment it's in anyways, and I really like working with a more challenging environment on a larger planet. In fact, Espa is mostly supposed to hover on the edge of human habitability. I'll elaborate more on this as we go deeper into the lore though. For now, the world's density being lower has a few implications. Firstly, plate tectonics should move more smoothly on average, meaning faster geological formations. Secondly, the magnetic field will be slightly weaker than Earth's. While this one is admittedly a bit tricky, it shouldn't have huge implications. Earth's magnetic field typically has a strength between 0.2 and 0.65 Gauss. So on Espa it may be 0.35 Gauss on average, depending on the iron concentrations in its core. The albedo refers to the amount of reflected light from a planet. Earth's albedo is roughly 29%, meaning that roughly 29% of the light received from the sun is reflected back into space. However, Espa will not reflect that much light. The planet on average will only reflect up to 17% of its received light. This will mean that our planet on average will be darker than the Earth. It's good to consider that Ojor is a weaker star than the Sun, only outputting 56% of its power. Therefore, it would be wise to suck up as much of that energy as we can, and reflecting 29% of it back into space would simply leave too little energy. A good way to accommodate this is to make Espa have more land area than the Earth, or to limit the extent of its ice caps or cloud coverage, which are the most reflective features on Earth. From this, we can then derive the average surface temperature on Espa, which is 15.6 degrees Celsius. This is slightly hotter than the Earth's 14 degrees, but that's fine. I'm quite fond of the idea of a large, tropical planet with a higher gravity. So that gives us some basic outlines of what the planet is like in a physical sense. While this is definitely still only some small facts, they already sketch rough outlines for the planet's topography. Next video, I want to spend a bit of attention on the Espan atmosphere and what it would be like to breathe on this world. I'll see you guys next time. Yeeji out.